Okay, we might as well get started. Welcome back to the stream and to the video, the Breadboard to Market series that we've been doing. If you like what you've seen, what you've been seeing, want to keep up with everything, definitely please like and subscribe. Hit that bell notification to be informed. We will be uploading to YouTube. I will generally try to stick with a minimum one video per week on Fridays, but because the depth of this project, I'm probably going to push more videos out per week on YouTube. I'm going to try solidify more of a schedule for streaming, definitely on Saturday and Sundays at 2 p.m. Eastern time. And then I'm thinking just going and sticking throughout the week, at least for now, Monday, Wednesday, and Fridays at 6 p.m. or generally around that time after I'm done with my normal day job. That's when I figure I'll be able to do the streams throughout the week. This project is a lot to cover, a lot we need needs to get done. So we'll get it taken care of from there. So last time we left off, we just pretty much got everything pushed over to the PCB editor, the layout editor, KiCad. All the components are here in one big old cluster. All the footprints, that is. And I've been kind of messing with things to reset an origin, set my snap to grid, everything. The dots, like you could do dots or cross. I kind of like the crosses, a little bit easier. Snapping to grid seemed to be really fine. Have to kind of be zoomed in a little bit to be better snap to grid, but that's fine. I want to fix the origin here because if you notice, so typically in most things, I don't know how many people remember their classes on basic engineering, science. So let's just kind of take this real quick. We'll fix it later. So let's say this is the 0 point. So everything's done in, ignore these lines over here, but everything's done in quadrants. You know, this quadrant, I don't remember the exact numbers. They're numbered, first, second, third, and fourth quadrant. And it's all based off the XY axis. So I want to fix this because typically, at least here in North America, so if this is your 0 origin point, if you move to the right, you're positively increasing the number. If you move to the left, you're decrementing the number. If you move up, typically on the y-axis, you are typically increasing the number. And if you move down on the y-axis below the origin, you are decrementing the number. So you're going in the opposite direction. So I got to reset this and flip the y origin around. And I think it's here. Under grid origin? No. Cancel. I just saw, I was messing around with things, kind of got things working. Preferences, I think. Okay, yeah. Y-axis increases up. Increases right. Okay. We're going to save this. So you can notice down here your XY coordinates. So the reason I put this origin here, this is basically the 0, this will be the 0. Technically, this is the edge of the board origin point. So let's get this guy cleaned up. Drag back over here. This is representing the edge of the board. And, all right. So this gray outline will be technically the edge of the PCB. Right now I need to kind of fix this. We'll fix it more. We may have to kind of drag things around depending on how we want to out our components, how we want to drag and drop them into the board. But this just gives us a rough idea. I think this is basically letter size. Typically, I like to lay out on tabloid size, 11 by 17. So I might try fixing that later. I'm not sure how. I'll have to, I mean, we'll see if we can lay this out. We should be able to. A bulk of the space is going to be taken by the pluggables. Obviously, we got a bunch of big components in here we need to get pulled over there, get plugged in. We're also looking at possibly a double-sided board. So that's, we can, we can move things around as necessary for that. So for now, let us start kind of basically doing some wire framework on how we want to plug and chug everything together. This is the 2-pin connector. We already know that is going to be the power. Let's see, the nets are named A out 1, so obviously that is the motor. That is the motor connector. Let's see what we got here. Negative, or A and B and ground. That is obviously the RS-45. And then these are obviously our 2 inputs, our control and our limit switches. Technically, they're both control inputs, but for sake on the board and how we want to lay things out, we'll just call them control. It's not going to hurt anything. They're basically the same, and they can be reprogrammed. So then we also obviously have our mounting holes. All right, so objects. All right. Okay, selection filter. So let's uncheck that. Let's just go with footprints. So when we're just kind of, okay, so this is great. So knowing how to, having this to be able to swap back around and forth will make your life a lot easier. So basically this way we're not like, okay, all items, we're trying to select the footprint. I was accidentally grabbing the pad, and that gets to be annoying. Or if you want to just grab a specific text or something, this lets you select what you want to just grab and work with. So we're just going to go with footprints. That way when I just click on it, I'm not guessing. I know I'm grabbing the footprint. These technically don't take any, or these are just the M3 mounting holes. Now I'm just taking some time and just kind of just roughing out on the board where they're going to go. Just kind of get an idea. We're not laying anything into stone. We're not setting ourselves up for heartbreak or failure just yet. We'll go through and we'll fix things. Basically just a rough sketch up, because we want to kind of get an idea how we want to lay this board out. Because we want to take into consideration any enclosure we may want to design for it. And do we, how do we want it to be shaped? Where do we want it to fit? Do we want it to be rectangular, more square-like? Do we want a specialized shape, special cutting or anything? So it's a lot easier just to kind of do some general layout and get an idea of where you want parts, and then start smashing out some final details. So one of the things I'm thinking is, let's say we have the board. If you haven't noticed, I'm still fighting that cold. I'm still fighting that sinus problem, and it's been hanging on. So pardon me if I yawn, sneeze, cough. I'll try to do my best to mute, so you don't have to hear that. Edit out what I can when I can. So I apologize in advance, and my brain filter still doesn't want to work right sometimes because of how I feel. But we'll go from there. We'll cross that bridge as we can, as we have to. So one of the possibilities is maybe 3D printing an enclosure that maybe could clamp on a DIN rail. for like a PLC cabinet or, or a control cabinet. Who knows? Who knows what somebody might want to do with this board. So we want to take the flow into consideration. So if you're snapping something like this on the DIN rail, powering it from an external power supply, and typically the parts, you're going to have very limited openings because you can have, terminals and other components on the left and the right side of the device. So your really only entries are top and bottom. So let's kind of consider that for a minute. So let's say we want, okay, R, okay. Again, this is just kind of rough framing everything, just creating a wireframe. Not set in stone. It's our control inputs. So the motor. We could kind of have the RS-45 down here. And then the power supply input by the basically the control inputs. Okay, that would work. That could kind of work. An argument could be made that the RS-45 would technically be an input, but it could also be an output if you're talking from here to another device. So here is probably a better point for it. Right next, up here maybe. Driving the motor down here. We also know we have the connector for the fan and the USB port for programming. For the standard USB interface programming for the ESP32. And then we have the next big part, the ESP32 itself. Again, we can populate a lot of this on the bottom, especially like the optos, the resistors for the optos, other components if we absolutely have to. Not a big deal. The motor controller, we could, but it'd be better just to populate it up here, close to this, to reduce the traces necessary to drive the motor pins. So we'll just kind of plan for that. We also want to make sure we have room for our fiducials. Let me select that because that's a footprint. Another reason. So that's the logo. We won't worry about where we're going to slide that guy right now. We want to make sure we have enough room for the big capacitor for the, for the stepper motors. That is the main bulk capacitor because of the instantaneous current draw. Without this guy, you will fry this poor little guy. I've done it a couple of times before I realized I didn't have a big enough capacitor, or the one wasn't connected in the first place. Then we have all these test points. We'll find homes for them. Not a big deal. So let's see, get an idea. We can start rough shotting some of these other components in. Let's say we want the ESP32. It doesn't have to be against an edge because it's got the IPEX antenna on it, but it's probably easier if we do. Let's just go and plan for that. We'll want the USB port. Now, since this is for programming, so here's where the interesting thing comes in. If we're going to throw this in an enclosure and strap it at a DIN rail, hopefully all the programming is done. Pardon me again. Oh, wait, that's not even the USB connector. I wasn't even paying attention. I got the wrong thing. This little guy right here. Hopefully all the programming's done. And it's already been tested. It's just kind of thrown in there, doing its thing. But we might want to kind of take that into consideration and kind of snake some of the stuff around a little bit. So let's kind of get these guys a little closer to the edge. We'll fix all that. We can even kind of bring these more in, depending. All right. Like I said, this is all preliminary planning. So it's showing the part number, and I'm positive that's not going to be printed on the board. You're only going to be the designators printed on the board. So for grins and giggles, let's see. 3D viewer. Huh. Interesting. Port only missing a malformed. Okay, it's upset because I don't have it. Huh. It's probably mad. It's probably upset about that. That's why it's not populating all the step files that we made sure. But here we got the connector, and we've got the mounting hole screws. Okay. Yeah, we'll fix all this. All right. I just wanted to see what that was. Okay. We got that big guy. Let's go and grab this fella right here for the motor. Okay. All right. So it looks like I got it wrong here. So it still wants to cross this over, and I don't want to do that, to be honest. Oh, what in the world did you zoom all the way out here for? All right. So what we're going to do is delete, 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 delete. We're going to save that, come back over to the PCB. Then we're going to save that just because tools, update PCB, update, close. And now it should have redrawn those air wires. Now they're uncrossed. That's originally what I want to do so we can avoid vias and doing that where we can. They can just be straight traces from these pins over to these connections. No vias, no jumping layers, because we can handle it in labeling and all that stuff. And in documentation. It's fine to have weird, as long as things are clearly documented and easy enough for the customer to understand, that's fine. Right now, we're just kind of rough-shotting this to kind of figure out if we need to increase the board size at all, if there's enough room for everything to sit on here. Okay, this is probably, yeah, that's the USB bridge. So let's say we do that over here. Put this guy right here. That way we get a nice clean connecting point from the USB positive and negative. That way we can, again, minimize vias and jumps from over there. Fiducials. We will want to at least make sure we have room for on the board as well. Yeah, we'll fix all the designators that we have to, that we can. So these three will technically be on the top. All right. Here. Here, let's just arbitrarily kind of throw some stuff together. Again, optos, resistors, a lot of the supporting components can be on the bottom. Like these resistors here can be bottom placed. I decided that I'm going to go ahead and do this as a 6-layer board. Okay. So what I'm going to do is we're going to go back to the layer stack manager. I want to make sure everything's right, because I may have done some stuff wrong before we get too far. I'm going to go to the PCB stack up. Where are you at here? Predator. Place view. Should be under edit. Board setup. I think. Board stack up. Physical stack up. Oh, because I think, okay, we want 4 or 6 layers. No. Now, can we select? So this is the first layer, top layer. I'm not terribly worried about any of this. Now, technically, this I would turn into. All right. Specifying color. See, because I would have a plane. I want to see about how. Okay, so here's let's see, top, inner. Let's see, top, plane, inner, plane. Wait, what? Copper layers. 1, 2. Oh, wait, copper. Here we go. Derp, copper. 1, 2, 3, 4, 5, 6. Usually you would select if it's a plane. Because if I've got my stack up, I want to be able to say this is a layer plane. Okay. This is going to make things a little bit interesting. So with other software packages, you can tell them that you want this copper layer right here to be like a power plane. And that's what I'm trying to figure out if I can do that. We're going to okay it. And I wonder if there is a way to... Your internal layer right there. Just have to grab open a... this over so I can look. Let's see here. See if I can do that here. Are you kidding me? Okay. All right. Just had fills on. Okay, we are on that layer. Add filled zone. Okay. All right. Well, before we start messing with that, boy, this is okay. All right. Because typically the planes, the power planes, once you select them into the layer stack up in the other packages, they automatically scale and understand their rules with the board and everything else. So before we go messing with that, let's kind of make sure we can fit everything on here. Let's see, that was that. That's the 45. That's for that fella. That could technically be on the bottom if it has to. Again, I want to try to just put all the resistors and capacitors I can on the bottom. So what we're going to do to make our lives a little bit easier, go to the schematic. Now let's go to the power supplies. So we know CN1, we have D3, the big shot key. See if we can find it in here. There you go. We're going to put that as close to this guy as possible. I mean, over there. Put that there. Since our power input is here, we may want to kind of keep the main power supplies like in line here. We may drag this guy down here. There should be enough room. So what might be easier is if we just kind of start laying it out, go from there, and then just fix it as we have to. Start by the origin, and then we'll move things out and adjust the outline as much as necessary. There's just no easy way to do this. But since origin is 0, 0 no matter what, let's see here. That must be the... We'll check text. Let's just grab that. That looks like the assembly, maybe. Don't need that tilde. I don't know. You have to show all that stuff. Oh yeah, we don't need that. We also need to really show the reference. And that'll hide the silk screen. We don't really need the silk screen shown. So let's see here. Is there a position XY? All right, perfect. So one of my favorite things to do, and one of the things I like to do with the ECAD software, I like to work by the numbers. So, okay. So 8 over, 8 up. Basically, the center from this origin, 8 millimeter over, 8 millimeter up. That's what I just did. It'd be nice if there was like a properties over here. All right, that's fine. But what we can do is 7 by 7. Okay. Okay. That should be all right. Should have enough pullback from the edge of the board, at least 5 millimeters. We could probably push it back a little bit more. I mean, yeah, you should be fine because the actual hole itself is far enough away. That should be a minimum half a millimeter right there to cover for the pullback and everything. So yeah, we'll go ahead and accept that. So now we have CN4. Okay. Yeah, so what's the... Okay. Huh. All right. So remember that. All right. Okay. So what are these? These are CN4, CN3. Move you back here. Fix all this here in a little bit. CN3 back there. Okay. Now we could put the power down here and then put these up here. Power down here. These guys up here. Technically doesn't matter. I'm not going to worry too much about it right now. It'll be fine. That pretty much just comes down to aesthetics. So let's see here. 13. Yeah, I wish that there was a little bit easier way that I could adjust that. Like since it's active, like a properties panel that would just like another tab up here. Is there a tab that I can do here? Should there be a tab? Maybe. All right. That would be great. Okay. Yeah, that would be great. Be great. If having that highlighted, there was a menu and I could just adjust the numbers over here without having to bring up the properties every time. Let's just say, is there like a tools? That'd be great. Yeah. Okay, that's just going to be a little bit more tedious. So Y's are up and down. All right. Okay. So we want to make sure we have room here. So that should be fine. X. Okay. So one of the reasons I'm kind of thinking about insetting this a little bit. Well, actually, I think I want to outset it a little bit. We'll probably bring it this way. 12. Oh, I mean, that would be fine. Puts that right on that. Which is typically okay. Some design rule checks will give you errors about that. So we'll kind of leave it like that. All right. So I'm going to move you down here. Because what I would like to do is we're going to go here to front top silk screen. We're going to throw in text. We're going to start kind of playing with it. Just gonna see. Or we can do it COM, common. All right, so that is CN4. So let's make sure we know what CN4. Interesting. That is control. There's your control inputs. So let's grab another text. CTRL 3. We could leave it like that. Whee, spin me right around, baby. Here we go. All right. And I think that's how we have it in the schematic. Let's double check. Yeah. Control 3, 2, 1. That's it, doesn't really matter. This would be control 2. Control 1. Let's see, and so we'll just call it CTL. Just to kind of abbreviate a little bit shorter. Okay, so we have the pin 1 designator there, which kind of throws up our plans a little bit, which is okay. No big loss. So we can do that. We'll go through and clean all this up later. I'm not terribly worried about it right now. I'm just kind of getting, again, the framework. X is 10.5. So come over here. And then 3. Leave a little bit of a gap, but not that much. Way not enough. That should be more than enough gap. So this pink boundary right here is typically what's called the courtyard. That is trying to define the absolute minimum space you should have between components. So we could technically go here. Oh. And I hit the wrong button. So 48.5. Okay. So basically what we did, the courtyards overlap. So that would satisfy the minimum the minimum space between these components right here is that courtyard. So what we can do then, this guy up here, and okay. So we're going to need to and that is LMT3 for limit. LMT2, limit 2. Limit input 1. Again, we'll go through and clean all these up, space those better once we have a better idea how we want to do this. I'm just kind of doing this so we keep it clean to when that way I can drop in the when I start dropping the other parts around it, I know I want to leave that space open so that silk screens to stay on there to help label those inputs or those connectors. So now for that guy, let's go ahead and hide those. Now, since that's there. Let's take fiducial 1. Let's hide these guys. I wouldn't show that. That's so annoying. Is there a way to show that? Well, is that fab? Oh, thank goodness. Let's just hide that. Those are fab notes. That'd be on the fab drawing. So let's hide that for now. So we'll take our first fiducial. Again, we're going to 2.5 is fine. So that's our first fiducial. Chilling out right here. By punching in the numbers and doing all this exact work, we might actually be able to shrink the board by having things more uniform, more universal. So that's a good thing. But one step at a time. There's no reason not to be patient. So 10.5 in. And let's go to 66. So put that there. And that's power. So it can kind of stay isolated. Okay with this board being bigger. Let's kind of so we can probably go to 67. Yeah, that's fine. So that is negative. Positive. Or what we can do is positive sign. and the minus sign. Put those there. That way they're there. Again, we'll clean them up. We can even go BC. Okay, okay. That's vibing, that's vibing. N is 5, so here. X is 5. Okay. We'll figure out our Y values on some of this in a minute. Again, we might have to go through and do some shoveling, some pushing, play some number games. But one of the things I want to try to do is kind of rearrange some of this. Since we're not doing an actual 24 volt plane, put this guy down here, which is fine. The motor connector's up here. RS45. And then just the USB for programming. Okay. All right. That's kind of, it's coming together. It's coming together. It's time consuming, but it's coming together. Okay. All right. Okay. Now, this guy about right there, we'll clean all this up, figure all this out in the long run. Fix it. Push it together. Whatever it takes. We'll make it work. Not a big deal. All right, so we have this guy as our input. And there. I figure the 24 volt, like a major power rail, the 24 volt can kind of come up here. Since we're doing this here, we should go and put the 3v3 and the 5 volt power supply in here. So the 3 volt power supply is going to get a dedicated power rail for it, or a power plane, an internal plane. So one's going to be 3.3 volt, the other one's going to be ground. But the 5 volt will just be traces to go wherever we need to do, wherever we need them. Because right now it's just going to power the fan. So there's nothing real special about it. So what we're going to do is we're going to go over to the schematic. All right, so that's that guy. We'll deal with those guys later and the test points later. So what we want to do is grab these parts, C1, C3, IC1. Yeah, so IC1. C1, C3. C1. C3. C1, C3. C5, L1. The inductors should be big fellas. So we're first of all, let's find C5. Okay, here's L1. Let's uncheck the text. There's C6. Here's C5. Okay. Okay. IC1, C1, C3, L1, C5. And then there should be two more capacitors, 7 and 9. 7 and 9. Here, I'm going to drag this group over to the board. Might as well have them close to the main 24-volt rail. And let's grab the other components, L2, IC2, C2, C4, C6, C2, C4, C6, and 8 and 10. Drag these guys over here too. Now we haven't laid them out, so obviously they're going to take up a lot of room, but we're going to get them really nice and cleaned up, get them laid out really nice and tight. So we should begin the power supply layout here. So this guy goes with these guys. So let's go ahead and no, actually that was okay where it was. So we'll go through and clean things up again later. These texts are pretty big. Let's see. Are they big? Width and height. Okay. Thickness. Yeah. Is there just I was hoping just to do your standard stroke. Yeah, we don't want to. So yeah, I wish there was a way we can do a stroke rather than an actual font, because it's too easy. All right. I'll take thickness according to text size. 1.27. All right. Gotta figure all this out. Because technically you want your height and your height and your text, the actual line width to be 25 mils is your text height, and your line thickness to be 5 mils. Let me go to my other window here and let's see here. So 25 mils to millimeter. So these should also be in your PCB layout guidelines. So for a 25 mil height equals 0.635 millimeter, and a 5 mil stroke 0.127. So our height, we can actually bring it down smaller than that, 0.635. And then the stroke All right. Nice and small. Nice. Uncheck that and just select all the text. Oh, oh man, this is not going to make life easier. Is there a way to change? Oh, this is not going to be easy. Okay, file, board setup. On the left under layers. Okay, here's where we do this. Okay. Bottom copper power plane. Oh, okay. Power plane. Okay. All right. Cool. That's where we do that. All right. All right. So signal, power plane, signal, signal, power plane, signal. All right. We're going to ignite just because. All right. Oh, geez Louise. Okay. Silk layers. Line thickness. 0.127. Text width. 0.635. Or yeah, 0.635. Copper layers, line thickness, gap layers. Okay. We're going to go to millimeters. All right. Those are defaults. Okay. All right. Now, unfortunately, that didn't go through and change anything. I probably should have done all that. Unless there's a way to update. Let me see. If tools, if I update. Update PCB. No. Didn't change anything. So we have to go through and update each one of those one by one. All right, well. So like in the other packages, I'm used to being able to select all the text at once and have the properties over here, and they all get changed at once. Yeah. Okay, well, let's go and let's not worry about. Because the annoying part of this All right, and a little more. All right, so we got those guys rearranged. All right, edit. Oh, okay. Hold on, there might be a way. Okay, edit. Text and graphics properties. Oh, there might be a way to do it here. All right. Under scope. Reference designator. Oh my goodness. Filters by layer. Action. Line thickness. Oh. All right. All right. Okay. That saved us a lot of headaches. All right. I love it. Okay. Okay. Ooh. Makes our life a lot easier. So what we're going to do then is, no, I have two windows open. So we are going to want to do our best to follow the data sheet for layout. And that is pushing the components, around the component, the main power supply chip, and the similar rotate orientation, placement, and everything else. Set up your planes, your copper pores, basically your polygon pores, and then kind of do all the plumbing to get them all connected. So typically what I'll do is, again, I work with multiple monitors. It's just easier. Since we're going to be doing it real time, it's not a big deal. It'd be just as easy for you to follow along here. So we know there's our 24 volt coming in. We'll consider like it coming up here as like the main 24 volt rail. That way you can kind of come up here and go straight to the motor controller and feed the two power supplies. Basically a bus, the 24 volt bus. That's the way it's not an individual plane. It's connected. It's there. And we don't have to worry about any of it. So, what we'll do then is, this is the 3.3 volts. Check that. Oh, we'll keep that. All right. Move these guys out of the way. And the great thing is both these circuits will get laid out pretty much identical. But we will start with the main IC. And I kind of like mimicking the way it's already set up in the data sheet. Pin one up here. And then all the other pins kind of follow in suit. It just makes life a little bit easier. So we have our boost circuit, which we know already goes to this capacitor. All right, so let's get this out of the way. That is, here's the big inductor. Goes off the switch. You out of the way. Now we have our main input capacitor. We're going to put there. We actually have two on the input, so again, we'll fix the designators in a minute here. All right. So that's our layout rough shot. There are no feedback resistors or other additional circuitry on that because this is just, it's not an adjustable system. It's just getting straight from the 3v3 rail and adjusting off of that. Never realized that guy was upside down. All right. So we've got a 24 volt in here. That guy's actually backwards. There we go. All right. So let's punch you by the numbers. 20, 67. Oop. That would really send your whole life flying. Kind of put you there. All right. So 24 volts comes in. Again, kind of up this way. Because it's going to feed this power supply and it's going to feed this power supply. What we could do if we really wanted to is take this power supply and build it up under here, and maybe that's what we'll do, and we'll have basically the 24 volt come down here to feed this power supply and that power supply, and then also come up over here to the motor controller. Maybe that's what we'll do, because we can put the opto isolators on the bottom of the board if we don't feel like there's enough room. We may not actually need to populate the bottom of the board. Right now, it's kind of looking promising. So again, I like to punch the numbers directly. So let's get you settled in on a hard hard coordinates. No, I don't know if anybody recalls, but one of the typical nomenclatures in PCB layout, especially with your designators or any general text like that, you typically want to have it set up to read it right to left, or I mean left to right, my bad, left to right, or bottom to top. And stay consistent as you place parts on the board. So we're going to set this guy right here. We're going to punch you in by the numbers. Courtyard, let's see. Y is up and down. Let's go 65. 65 is good. Then we're going to punch you a little closer to that guy. 30? No, too close. So, yeah. All right. Looking beautiful. So this will be about where the boost cap is, because it's going to be fed from the output. So let's kind of let's get the main inductor punched in. You typically want to push it up against the pins as closely as possible. So we can probably go another millimeter. It's getting it kind of tight. Let's go 40 and a quarter. All right. And all right. Okay. 69. So this guy would be the boost cap. Make sure 38 by 72. Let's go to 72. Get that designator lined up nice and neat. And now we've got our output filter caps. Realistically, we can kind of punch this guy up here. Give you 44, 66. Let's get you down here. And we can actually punch you up a little bit higher. Too high. 67, so 67 it is. And punch you a little closer to your friend there. Now, one of the things we got to keep in mind is we're going to be hand assembling these. And another thing to keep in mind sometimes is repairs or rework. Sometimes if you overcrowd your parts, that makes it too difficult to make repairs or do rework to solve for future issues. Typically, you don't have to worry about that, but during the earlier prototype phases, it's something you might have to, but you aim not to. So we've got the 3.3 volt kind of plumbed up. Let's get the figure out, get the 5 volt kind of started there. Because it's going to be pretty much following the exact same stop. This will just get it cleaned up so it's out of the way. Boost. All right. So that is nice and good looking. And what we'll do is we'll just go ahead and 36 in. Nope, 36. And we probably bump you up a little bit. You should be far enough from the other power supply to not cause a problem. Leave you there. 38 in. Okay. All right. 32. And 50. Looks about right. And then that is 29.5 by 50. All right. This inductor, 40.25. And that is also 54 up. All right. Well, we got these guys. 44. 48. Now, push this up to 51. 52. 52 looks good. All right. Don't do that to me, please. Drag these guys, get them kind of snapped and looking a little nicer. All right. These guys are kind of where we could use them. Again, things are kind of densing in really nicely that we're punching things together. Let's go ahead and pull over the other parts of the power supply here. So we've got R1, R2, D1, and D2. 1, R2. Okay, so D1, R1, D2 with R2. So these are the power good indicators. They can technically go anywhere. They don't have to be by the power supply. I just find that sometimes it's easier to go ahead and do that, to go ahead and allow them to be on the power, to be by the power supplier. There's a power supply rails. It's just easier identification. Let's go and grab the test points 1, 2, and 3. They can go over here. All right, so D2, R2, R2D2. All right. So what we can do is, so it's going to actually be kind of plenty of room up there. Because we're tying ground planes together. How do I want to do this? I don't want to run unnecessary traces or vias if I don't have to. You want to try to avoid doing things just unnecessarily, like traces and vias that you don't have to do. So we're going to, either way, we're going to have to do something. Because we have this kind of gap right here above these. So it might actually not be a bad idea to take this. I'm going to do something like this. 46 by 60. I'm going to do this 46 by 57. All right. I mean, it is a power supply. So it's kind of feed off of here, then here, then here. We have 5-volt okay. What we could do, no, leave that alone. So I could put the resistor on the bottom of the board, but if we can avoid populating the bottom of the board, that's even better. So that's what we're aiming for, is to not have to populate the bottom of the board. So then we're going to come up here. It is 46 in. And this is also 46 in. All right, so we're going to pump this up. 72. And this 75. 3-volt, okay. So what we can do is probably move this guy over a little bit. As long as we're not encroaching on the silk screen or the pad too much, as long as we're not too close to that, we should be fine. All right, so that should be good. Then what we could do is kind of do this. Here, test point there, test point there, and then the ground in between. So let's go to 60. I don't like crowding out my test points too much, so I can leave that 0.5. That's fine. All right. So we just leave. All right. That will be acceptable for now. See if we have to fix any of it. Because we still, pardon me, we still have to bring in all the parts, the components that supports the stepper controller, the stepper driver, all the parts for this, but this should be fine because I haven't pushed this over. This board size may actually work pretty well for what we're doing. It's actually kind of funny how it's actually I just kind of slung it together and it seems to be okay. So it might actually work. So we've got that plugged in. We can route that over there. All right. So what I think we'll do is we'll end the video here and the stream here. There's still a lot to go. It's PCB layout is just as rough. It's just as time consuming as the schematic capture. It's just more focus intent and more purpose driven. Because, well, a schematic, yeah, you want to make it readable. You want to make it look nice. You want it to be human readable. And that's fine. And that can take many shapes and forms. But this is where the real work begins, because this is going to be the physical product. This is where you have to make sure you get things right. Because if you make a mistake in laying out here, this is where you've spent money unnecessarily. The cheapest place to find mistakes and correct them and to make sure everything's done right is right here. Before you've ordered any parts, before you've spent any money, especially of your own, or even your customer's money. So if you're doing contract design and manufacturing, that is probably worse than accidentally spending your own money, is spending your customer's money unnecessarily and maybe contributing to waste. If it's, things happen, mistakes happen. We're only human beings. So that is still a real possibility, but you want to try to avoid as many of those problems as possible. And this is where you catch your mistakes. So again, we'll end the video here, and tomorrow I should be streaming probably around 2 in the afternoon, recording the next video for YouTube, and hopefully we'll get more of this pushed along. Thanks for catching, and have a good evening.